Writing electronic configuration of an element. Things to be kept in mind while writing electronic configuration. 1. Atomic number, that is Z, of an element. Second, sequence of the subshells according to above principle. Third, maximum capacity of the subshell to accommodate electrons. And fourth, Hund's rule of maximum multiplicity while writing valence electronic configuration in box. Now let us see what is atomic number, that is Z of the element. Atomic number of an element is either the number of protons present in the nucleus or number of electrons revolving around the nucleus. Electrons equal to atomic number are to be distributed in different subshells while writing electronic configuration. Above principle and N plus L rule. Electrons will be filled in the different subshells in increasing order of energy levels, lowermost being filled first. Now how to decide energy or energy level of the subshells? This can be decided by N plus L rule. Lower the N plus L value of a subshell, lower is the energy of that subshell. What is N here? Here N is equal to principal quantum number, which can have value from 1, 2, 3, 4. K shell has N is equal to 1, L shell N is equal to 2, M shell N is equal to 3, and capital N shell small n is equal to 4. What is L? L is the azimuthal or secondary quantum number. L can have values for different subshells as S subshell 0, P subshell 1, D subshell 2, and F subshell 3. These are N plus L values of different subshells, and from these values we can have or we can write the sequence of subshells in increasing order of energy. Now how to calculate? Example, 1s subshell is having n is equal to 1, L is equal to 0, therefore n plus L value is equal to 1. For 5p subshell, p is n is equal to 5, L is equal to 1, so n plus L is 6. In this way, we can calculate n plus value of all these subshells. Now suppose two subshells have same n plus L value. Then which one will have lower energy? Let us see the example. Example, 2p subshell and 3s subshell both are having same n plus L value, that is 3. So in these two subshells, which will have lower energy? The one which is having lower n will have lower energy in such case. That is, in 2p and 3s subshell, 2p will have lower energy because for 2p subshell n is equal to 2 and for 3s subshell n is equal to 3. So if both the subshells are having same n plus L value, then the one which is having lower n value will have less energy and that will field first. Now let us see example of 4s and 3d. 4s subshell is having n plus L value 4 and 3d is having n plus L value 5. As for a subshell, though it is from the fourth main shell, has less n plus L value, it will field first and then 3D subshell will be filled though it is from the lower main shell. So in this way we can have a sequence of subshells like 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, etc. which is written on the slide. Here we can see sequence of subshells in the form of diagram. Energy increases in upward direction. So K main shell, which is having the least energy, it's shown at the bottom, which is having one subshell, that is 1s. 1s has only one orbital. So one orbital can have two electrons. Thus K main shell can have only two electrons. Next comes the L shell with small n is equal to 2. It is having two subshells, 2s and 2p. 2s is having one orbital, 2p is having three orbitals, 2px, 2py, 2pz. 2s can have two electrons, 2p orbital can have 3 2s are 6 electrons. So total second main shell, that is n shell, can have 8 electrons. Third main shell is m shell with n is equal to 3, that is principal quantum number is equal to 3. It is having 3 subshells, 3s, 3p and 3d. 3s is having one orbital, that is 3s orbital. 3p is having 3 orbitals, that is 3px, 3py, 3pz, and 3d is having 5 orbitals. 3s can have 2 electrons, 3p can have 3 to the 6 electrons, and 3d can have 5 to the 10 electrons. So total 2 plus 6 plus 10, that is 18 electrons, can be accommodated in M shell, that is third shell. Now here you can see that 3d is having more energy and 4s, though it is from the fourth main shell, it is having less energy. This is according to n plus L values. For 4s, n plus L value is equal to 4 and for 3d it is 5, that we have seen in the previous slide, and on the basis of that energy levels this diagram is drawn. So though 3d is from the third main shell, 4s is filled first with 2 electrons, and then if electrons are to be filled, electrons are filled in the 3d orbital. The next main shell is n capital N, that is having principal quantum number small n is equal to 4. It is having 4 subshells, that is 4s, 4p, 4d and 4f. 4s one orbital with 2 electrons. 4p is having 3 orbitals and can have 3 to the 6 electrons. 4d is having 5 orbitals and can have 5 to the 10 electrons. And 4f has 7 orbitals and can have 7 to the 14 electrons. So together in fourth main shell, that is nth shell, 2, 6, 10, 14, that is 32 electrons n main shell can accommodate. And this is equal to 2n square rule, where n is equal to principal quantum number. Hund's rule of maximum multiplicity. When we have to fill up electrons in more than one orbital, then we have to use Hund's rule of maximum multiplicity. If two or more orbitals of equal energy are available, electrons will occupy them singly before filling them in pairs. That means all the orbitals will get singly occupied first, and when all the orbitals will be half filled, then and then only pairing of electron will take place. Suppose we have to fill up 4 electrons in the p subshell. P subshell is having 3 orbitals. So let us see the correct way of filling up the electrons. Now 2 ways are shown here. The first way is wrong way, in which only 2 orbitals are filled with pair of electrons. But the third way is correct, second way is correct way, in which all the orbitals are singly occupied first, and then when all the orbitals are half filled, the fourth electron will form a pair. Second example, 7 electrons are to be filled in the d subshell. D subshell is having 5 orientations, that is 5 orbitals, and here 2 ways of filling of electrons are shown. Now, according to Hund's rule of maximum multiplicity, all the orbitals should be singly occupied first, and when all the orbitals are half filled, then the next electron will get paired. So in the first way, 7 electrons are filled in such a way that 3 orbitals are having pair of electron and 4th orbital is having a single electron. But that is wrong way. In the second way, 5 orbitals they have filled up singly first, and then 6th and 7th electron has formed the pair.